Welcome to Owie and Sandy Math Along. I'm Sandy.
And I'm Ollie!
This is question number 1 on the AppleRouth assigned lesson, triangles. Okay, it's the first time that I have done an AppleRouth assigned lesson, so we'll see how it goes. I want to try to get these done because sometimes they ask you questions that they just didn't prepare you for. So hopefully by me going over examples, you will be prepared for what you see. The first question, they give you a house and they tell you that the roof forms an isosceles triangle where the upper point is 120 degrees. Your number's different, mine's 120. What is angle X? Okay, yours says A, mine says X. So they tell us it's isosceles. Isosceles means we have two sides that are the same and we have two angles that are the same. So I'm going to call that X and X. Now I know the whole triangle has to come up to 180 total degrees. So we're taking up 120 of those degrees already. 180 minus 120 leaves 60 degrees to be split up amongst those two angles. Well, it's isosceles. Those two angles are the same thing. So we can take 60 and divide it by 2. That means both of these angles are 30 degrees. Okay? Pay attention to the numbers you have, but this is fairly straightforward. You should be able to figure it out. Number 2. Number 2 is asking you about a triangle in the coordinate plane. Now, on AppleRouth, none of the example problems they give you from the book or from the videos talks about triangles in the coordinate plane. So this is one of those where I feel like it's a little unfair for them to ask you about it before going over it. Therefore, I felt it necessary to go ahead and project it up here and show you the whole thing. Hopefully you can see it okay. I know there's a glare from the projector, but in the standard XY coordinate plane, which I have drawn, triangle DEF has vertices at 3, -5, -6, -5, and F, -6, 4. What is the area of the triangle in square coordinate units? So immediately I know we're using 1/2 base times height before I know anything else because it's a triangle and we're finding area. Now I'm going to plot those points that we were given. First, 3, -5. It's written up there. So we go in the X direction, 1, 2, 3, and we go down, 1, 2, 3, 4, 5. We are going to be right about here. I'm going to go ahead and rewrite the coordinate, just so I don't get confused. E is -6, -5, so -6 in the X direction, 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, and that lines up perfectly which is great for us because they are both at the same value down here. F is -6, 4, so -6 up 1, 2, 3, 4 puts us right here. And that one's lined up perfectly with that one. Okay, so this isn't quite as hard as you may have done in your geometry classes because you don't have to use the distance formula. Because these are in a straight, flat, horizontal line from each other, this is in a straight vertical line, making that 90-degree angle. We don't have to use distance formula. Instead, what we can do is count how many units long and tall this is. Remember, we need area 1/2 our base times our height. So on the base, currently, I'm I'm just gonna, okay, just to double show, right, we're at 3, okay? I'm gonna count this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Brings us here. So the total length of our base counting is 9, okay? I can put my 9 in. Now I need to find my height. Well, our height, we're currently at -5, okay? -1, 2, 3, 4, 5, right here. And I'm gonna count how many units up until we get up to this one. This one's at a +4, okay, just to remind ourselves. So I'm counting up 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again, that was a coincidence. I didn't even mean to do that. That actually makes this a special triangle because if you notice a 9 and a 9, it's kind of like that one we just talked about. It's isosceles. Okay, that actually doesn't matter in the course of this problem, but at least we can recognize it. So 9 is also my height. Area equals 1/2 of 9 times 9. 1/2 of 81 is 40.5, okay? And they asked in square coordinate units. So I'm gonna put coordinate units squared, okay? But the important part would be the actual number. Of course, it's not shown here because I made this one up. Yours will be different. Number 3 on the Triangles AppleRouth assigned lesson. We have a weird figure, and they give us a series of information about that figure. LP is 10. I'm going to go ahead and write it in as I say it. So LP from here to here is 10. PO, this whole part down here is 16. If I write this in, I hope you can see it okay. 16. X is the midpoint of PO. So that means if this is 16, this is broken up into 8 and 8. Okay, you'll be able to see that. Angle MLP, and LPO, okay, LPO are right angles, so I'm going to put that square in there. They want to know what is the length of LX. Wow, well, LX, I'm going to draw that in with a different color so you can differentiate between what we were given and what we're being asked for. L to X. Now, there's no indication that that is a 45-degree angle or not. It shouldn't be actually, because if this is 10 and this is 8, that's not going to be a 45, 45, 90. It's not going to be isosceles, and it's not going to be equilateral. So what can we do? Well, I have a triangle. I have a 10 and an 8. I want to know this length right here. This 90-degree just got split up, okay? This one's still intact. And if you notice, like we talked about in class, it's pointing here, which means this is a hypotenuse for this triangle. Okay, so I'm going to call it C, right? And we are going to use the Pythagorean theorem, a squared plus b squared equals c squared. This week doesn't matter which we call a and b. So I'm just going to say 10 squared plus 8 squared equals c squared. That's 100 plus 64 equals c squared. That's 164 equals c squared. Now, to get C by itself, I need to undo this square. I can do that by taking the square root. What you do to one side, you have to do to both. So I'm going to move now over here where will be visible the square root of 164 equals C. Offhand, let's see. I know a 4 can go into that. So let's do our little tree. A 4, which is a perfect square, okay, times 41, right? I believe 41 is a prime number. Nothing goes into it. So the square root of 4 is 2, and the square root of 41. I would leave it like that. If your answer choices are in decimal form, you could figure that out. I have a feeling your answer choice is not going to be in radical form or decimal form. You probably have one that's going to be a whole number. Okay, let me get out of your way so you can see the process one more time. Once we set up exactly what we were looking for, we were able to recognize this triangle right here is a right triangle, identified our hypotenuse, our 2 legs, and used the Pythagorean theorem to go through to C. Number 4. We're given a circle, and in that circle, we have triangle OBC, where C and B lie on the circle, and O is the center. They tell us BOC, the angle BOC, is 70. So angle BO to C is 70. What is the angle OBC? I'm going to put that in a different color so we know what we're looking for. Angle OBC, okay, would be this angle right here. This is similar to something you had in last week's work. Last week we did circles and they gave you some like this. Well, obviously this week we're looking at triangles. We're looking at special triangles, 90-degree angles especially. So I am going to cut this in half, right down the middle, so that now I do have a triangle that is a right triangle, okay? When I do that, I'm bisecting this angle. So now we have a 35-degree angle on each side, which together makes that original 70, okay? I also have a right angle, which means now I have a right triangle. I'm going to outline that for you just so maybe you can see it a little better. Let me use the blue. I think it'll show up. Kind of cool. So now I'm just going to focus on this one triangle. It has a 90-degree angle. It has a 35-degree angle. We should be able to find our last angle fairly quickly on that, right? If this is 35 and that's 90, the whole thing should be 180, okay? Subtract 90, subtract 35, that leaves us with what B is equal to. I don't think I need to go any further. If you need to use a calculator, use a calculator. 180, subtract the 2 that we know, and that's going to give you angle B, aka angle OBC. Number 5 is another example of the coordinate plane. Again, they did not give you any examples in the quizzes, in the videos, or in the book regarding the coordinate plane and triangles. It is an important skill for you to know for the test though. So I am going to give you some really good hints here. I'm not going to solve the whole thing outright, but I'm going to lead you in the right direction. So we are looking at points -5, -1, and -2, -5 in the standard coordinate plane. It wants to know the distance in coordinate units. Now, there is a distance formula. So first and foremost, if you are currently or have taken geometry before, This is the distance formula. If you are comfortable using the distance formula, by all means, use it. Okay? If you want to use it, use it. Okay? And if you're in geometry, you've probably been doing this, you know like the back of your hand right now. But if you don't know that, or it just looks scary in general, then let me show you how we can do this using the lesson we're currently on, working with right triangles. Let's plot our points. -5, -1 goes right here. And -2, -5. I need a drink. So much talking. Okay. We want to know the distance between here and here. If you're using the distance formula, you could call this x1, y1, x2, y2. I'm not going to do that. Here's what I'm going to do. I'm going to make a right triangle. I know this comes 1 unit down, and I know this comes 1, 2, 3, 4, 5 units down. I'm going to come up to here and to here, okay, which I know my drawing isn't perfect and I don't have a perfect coordinate grid here, but that brings me to point -2, -1, okay? My next step is to recognize my 90-degree angle. What's it point to? The hypotenuse. And what length are we looking for? The hypotenuse. Okay? So we know this can now be an a squared plus b squared equals c squared problem. Number 6. We have 2 girls, Anna and Elsa. Looks like they are at the gym and they are each going to bike home. We want to figure out, once they take these directions home, how far apart do they actually live from each other. So Anna's at the gym. I'm going to call that gym. She bikes 8 miles west. Okay, here's your directional: north, south, west, east. Never eat soggy waffles. That's the one. That's the one. Or naughty elephant squirts water. Or I just remember we, but hey, that's me. All right, so we're at the gym. We bike 8 miles west. So that's this way. 1, 2, 3, 4, 5, 6, 7, 8. Then she bikes 6 miles south. 1, 2, 3, 4, 5, 6. Okay, and that's going to be an A for Anna's house. Elsa leaves the same gym. She goes 5 miles east. That way. 1, 2, 3, 4, 5. And then she turns 2 miles. 1, 2, north. I ran into my coordinate plane. That's an E for Elsa. Coordinate plane. Oh my gosh. I ran into my directional. And that's where we're at. So now we want to know, how far do they live from each other? We're going from down here all the way up here. And you notice we're not crossing the gym. Okay? We're going in a straight shot from house to house, but it doesn't cross the gym. Okay, it doesn't have to. All right, and let's just reiterate to ourselves how long each of these things are. 1, 2, 3, 4, 5, 6 up. But if we're going to go all the way up to Elsa, we're going to go 2 more. Okay, so we're actually going from here to here. up 8 total. And then we're going from here straight across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Across is 13. Okay? What does this look like? This outside part. I mean, other than a mess because it's me drawing it, but we have, I colored the wrong one, 13 down 8. We have a right triangle because she took a turn due west or due south from west. I have a hypotenuse, so I can call that C. I have 2 legs that I can call A and B, which means I have 8 squared plus 13 squared equals hypotenuse squared. 64 plus 169 equals C squared. That would be 233 equals C squared. Take the square root of both sides to get C by itself. And I'm going to come up with some kind of a decimal answer. You can use your calculator to get closer to the right answer.